start.
It is my pleasure to welcome you to the second session of the World Water Week seminar on navigating multiple crises while facilitating synergies between adaptation and mitigation. My name is Anna Tengberg, and I am a senior advisor at Swedish Waterhouse at SIWI, where I work with a program on water and resilient landscapes. We are very pleased to be a co-convener of this seminar, and I would also like to thank the other conveners, the Swedish Society for Nature Conservation and the Alliance for Global Water Adaptation. First, some housekeeping issues before we move to the session. You need to be aware that this meeting is being recorded, and you should stay muted if not talking. And then you can use the chat in Pathable to ask questions throughout the session, and we will make sure to answer all of them even after the session is closed. And today we are focusing on innovations and transformations in the water sector that can help foster and harness synergies between climate change mitigation and adaptation and avoid or minimize trade-offs. Several IPCC reports, including the special reports on water as well as land, have highlighted the need to urgently find solutions to the climate and associated water crisis. Solutions that work with rather than against nature can more easily harness the multiple benefits provided by ecosystems, such as regulation of the water cycle and sequestration of carbon in soils and vegetation, as well as provision of food, water, and other ecosystem services important for human well-being. This will also put us on the right path to achieving the targets of the Paris Agreement and the Sustainable Development Goals in a synergistic and timely manner. Today, we will have an interactive session with several examples of integrated and innovative solutions from urban to rural settings, spanning different scales from site-specific implementation of nature-based solutions to integrated landscape planning and management. We hope that these presentations will inspire and trigger new ideas about how to achieve synergies and how to remove institutional, technical, behavioral, as well as other barriers to scaling up innovations. And I now hand over to Louise Karlberg from the Swedish Society for Nature Conservation, who will introduce the speakers and also facilitate the discussion. And again, warmly welcome to the session.
Thank you very much, Anna, for that nice introduction to the day. Perhaps you around the world sit there and think that it's such a pity not to be gathering here in Stockholm today physically. I think so. However, you should count yourself lucky because we have terrible weather here today. It's pouring down with rain. So something good about sitting at home in front of the computer. So my name is Louise Karlberg. As Anna said, I work for the Swedish Society for Nature Conservation. That happens to be the largest environmental NGO in Sweden. And I'm also a member of the scientific program committee of this week. So we have a setup with 4 fantastic speakers. I have been given the privilege to see the presentations beforehand. They look so exciting. So I look very much forward to listening to them. After we have heard the speakers present and giving us their stories, we will have a panel discussion, which I will moderate, and that's the setup for today. So we have the chat where you can ask questions and the speakers can respond to them either during this hour or after 10 minutes after the presentation as well, or the session today. So first out is Luca Di Mario. Luca, you work as an urban development specialist at the Asian Development Bank. I know that you have worked in lots of dry places in the world, but right now you are deeply involved in a project in India where you combine using dams for multiple purposes. The floor is yours, Luca.
Hi, good afternoon, good morning, or good evening, everyone. Thanks a lot for the introduction. So in this session, I would like to share the experience from a pilot project that our team is running in Visakhapatnam in the state of Andhra Pradesh in India, which integrates adaptation and mitigation solutions and really connected with water. The pilot is supported by the Urban Climate Change Resilience Trust Fund within ADB. So this pilot is actually part of a larger program that ADB is supporting in the state of Andhra Pradesh. And this program aims to basically improve the manufacturing sector in the state. So it's basically an industrial development project. And there's different components, aiming to develop policy, infrastructure, and institutions. And within the sort of policy, the infrastructure development, so basically the project is also looking at developing sustainable urban water supply in some of the nodal towns across the infrastructure corridor. And one of these is Visakhapatnam, which is a coastal town in Andhra Pradesh. And as core project, we're actually supporting and developing drinking water supply system, continuous drinking water supply systems through adopting no revenue water reduction. But also in Visakhapatnam, we are running this pilot that tries really to address and integrate adaptation and mitigation measures. The pilot is around $5 million cost. So just to give you like a very brief introduction of Visakhapatnam, it's as I mentioned, it's a coastal town of a population of around 3 million people, and is a major tourist destination and the fifth business cargo port in India. It's also, an industrial town, of course, being part of the corridor, and the climate is a tropic wet and dry climate. And basically, of course, with the effect of climate change, we see, a decreasing precipitation trend, and of course, higher frequency of extremes events. And in terms of electricity supplies, mostly from coal power. As I mentioned, the core, project that we are running in Visakhapatnam is looking at continuous water supply with no revenue water reduction. And in a way, this is already, a very good, important intervention about conserving water. Basically, stressing on the fact that water losses must be reduced, also in view of climate change. And this has a positive effect on mitigation and, of course, on adaptation, given the, high water availability. But this is not the pilot I wanted to talk about. So our question was actually, how can we further, enhance the climate resilience in Visakhapatnam? And discussing with, our clients, we basically, agreed and designed actually to basically to run a pilot that would integrate, further adaptation and mitigation components. So this pilot has three, let's call them sub-projects. So one looks at, generating renewable energy while minimizing land footprint. So with the installation of a 3 megawatt floating solar photovoltaic plant in a reservoir within Visakhapatnam. So it's a drinking water reservoir. The second sub-project is about basically providing, more water availability in terms of storage, through really improving the watershed and a natural reservoir, help managing better. And then the third one is, let's say, less connected with water, but more on, with transportation. It's about piloting e-vehicles. The focus of the pilot is really, the aim was really to have a proof of concept for higher stakeholders buy-in, especially about the synergies between adaptation and mitigation. Because, for example, the solar power plant is actually on a reservoir, right? On a drinking water reservoir. But also, look at what are the challenges and, in implementing this kind of, let's say, innovative approaches, as well as build capacity to design, procure, and operate and maintain. So really also from a practical level. These three sub-projects were not selected randomly, but are part of a wider smart city master plan that the city already has approved. But no project was implemented by that time. So we really wanted to prove on from an implementation and practical point of view. And this is the same, in terms of the reservoir for the drinking water part. So just to give you like a very brief picture how the things looks like, basically this solar park on a reservoir, on a floating solar park on a reservoir, while also enhancing the capacity of this reservoir and improving the water quality and the water level monitoring that at that time was not present. There's a project regarding the watershed development and rejuvenation. It's really looking at improving soil and water conservation, while really desilting the reservoir, clearing the bushes and the weeds blocking the drains, enhancing groundwater recharge through 60 recharge pits, and enhancing all the vegetation and the green cover around the area. And we really, with the aim that it would really demonstrate on how you can improve the water availability and water storage through these simple measures. This is just like a Google Google map on the on what's going on this Mudar Salova watershed, which is basically a reservoir, again another reservoir within Visakhapatnam. Yeah, this is in summary what are the pilot's outputs, and as I mentioned, design, procure, installation, and operation and maintenance for the solar park. And in terms of the reservoir, yeah, I already mentioned what are the measures in terms of groundwater recharge and planting vegetation. Just to conclude, I mean, what is the status and the lessons learned? I mean, the pilot started 2 years ago, and I have to say the first comment that I have, it's not ideal to implement a pilot during a pandemic. So we had a lot of delays, and we had to face a lot of issues because of lockdowns, and we hope that the completion will be achieved in about six months' time. In terms of the second sort of point that I wanted to make is that the grant funding, this $5 million, within a larger investment of $400 million, was really proved crucial to pilot innovative ideas that were not really established in the mindset of the client or the, let's say, classic engineer. So those are very simple measures that we all know, but often we really need I think a grant has been instrumental to really help us to prove this concept. I think it was also very good to have a good understanding, that the officials had a good understanding and engagement on this idea, also thanks to the wider smart city master plan that was there. And they could really, I think, appreciate the link with the wider investment and also the clear benefits. And finally, in terms of the market on how you implement these sub projects, I think for the floating solar and the watershed, that's been quite easy. Those are quite simple, and the market participation has been quite easy to let's say quite good. Instead, for the e-vehicles, which I haven't had discussed in details in this presentation, it was a little bit more challenging, let's say. So with that, I finished my presentation, and I would like to thank, of course, for your attention, and also my colleagues Akira and Virinder Okchu, and of course Ashwin, the co-presenter, for the good teamwork on implementing this pilot. Thank you.
Thank you, Luca, for that exciting presentation, and thanks also for sticking to time. So we're going to travel from one continent to the next now, but from one dry region to the next. So Maxime Fortin, you're the project director and water resources engineer at Co-Water International. And you have, just like Luca, worked in many dry regions of the world. Right now, you're heavily involved in a project in Burkina Faso, which seems to, judging from your presentation, be doing a lot of very exciting things, from sanitation all across to agricultural intervention, if I understand it correctly. The floor is yours, Maxime.
Thank you very much, Louise. I'm just trying to make sure I'm sharing the right screen here. You see the full PowerPoint view?
That looks very nice, thanks.
Perfect, thank you. So thanks a lot for the introduction and Luca for the first presentation. Now we will be presenting a case study on the integrated water use for livelihoods in crisis affected Burkina Faso. Before we dive in, I just wanted to say a few words about Co-Water, which is an international development consulting company based in Canada. Basically, we are both implementers and advisor. We work with bilateral, multilateral donors to implement projects across different service lines. And of course, the main one that will be discussed today is the water, climate, and agriculture service line. And I would like to present my colleagues, Laure and Mark, who also contributed to the presentation today. So in introduction, we move from the wet climate of Visakhapatnam to the Sahel region of West Africa, where there's a very different situation in terms of water availability, and the challenges and realities might be a little bit different. What we found when we developed this project that will be presented as a case study today is that there was very limited water available, both for drinking water and other economic activities, and that was contributing to fueling more poverty and insecurity in the region. There's been an important increase in armed conflicts and a lot of climate stress that are reducing the viability of different livelihoods. And we'll say a few words about that. That was a key factor in the development of the project. So the ESED Sahel project was born with the objective of leveraging water as a key development tool in different cross-cutting ways. So not looking at just one sector, but trying to see, okay, how can we, with the local government and local partners, provide clean drinking water, but also contribute to the agricultural and pastoral livelihoods in the different communities, and use some innovative approaches such as the social arts for behavior change that was championed by the One Drop Foundation and then integrated across some of our activities. So the project in itself was implemented over a duration of 5 years. It was a phase 1 that lasted 5 years, and the second phase is currently being planned right now. We had a total budget of about 12 million euros that was provided by Global Affairs Canada, about 2/3 of it, and then the remaining part was provided by IAMGold, which is a Canadian mining gold company operating in the region, and the One Drop Foundation. So it's a bit of a twist here in terms of public-private partnership that we'll discuss in more details. Of course, we had the main technical partners in the country with the national utility company and the different ministries that we collaborated with, and the different objectives that are already mentioned previously. In terms of local context, for those that are less familiar with Burkina Faso, it is a small landlocked country located in West Africa with a population of about 20 million people. It is ranked 182 on the Human Development Index, and that might have decreased a little bit more since the last rankings or the last assessments were done. There's been a very important rise in insecurity in recent years, and that's been having a profound impact on the development in the country. So in particular, in the Sahel region, which is one of the poorest regions in the country, in the northern part of Burkina, with more than 80% of the population relying on subsistence agriculture. The access to water supply and sanitation is quite low, and that's proving to be a key barrier and limiting factor in enabling economic development in the area. And the climate is very dry and arid. So if we compare to the 1,000 millimeters that Luca was presenting just before, we're dealing with 60 centimeters of rainfall per year, which is quite low and can be quite a challenge. So here we have an overview of the project area, and we're kind of diving into where the project was intervening and what was being done. You can see the famous water triangle. Well, I'll say famous, maybe famous if you're in Dori, but you would not have heard of it where you are now. But that's how it was being referred to by the local media and local community and partners. The triangle is formed by the regional capital of Dori, which is the capital of the Sahel in Burkina, and the towns of Gorom and Falaguntu. You have the IAM gold mine that is located here, just here. You can actually see the footprint on satellite imagery. And more importantly, you have the Yakuta reservoir, which is a 26 million cubic meters water reservoir that is used for different usage, drinking water, agriculture, etc. So the main water supply activity was to leverage the water available in this reservoir here. The dam was already built, and we added the water treatment plant that is providing water to the city of Dori, so about 60,000 people. And that's a phase 1 of the project. And there is the phase 2, as I mentioned before, that would move to expand the water supply to Gorom and to Falaguntu, which would be some very important investments in the region. And the livelihoods development activities, the community wash, the school wash, social art components were implemented across the project area. So you have a focus on water around here, but there's a lot of community wash being done in rural areas and rural villages here. So some of the key results that were achieved, because the project was completed last year, thankfully just before the pandemic started. The design, procurement, and construction of the water treatment plant, that was a very big challenge in that context and in environment that is still operating for over 60,000 people. The community wash was an important aspect, and the social art really added a new perspective to things. We had a very detailed communication strategy that was developed, identifying key behaviors and key messages that needed to be passed along and addressed for effective, as an example, hand washing, use of latrines, washing latrines, school wash, etc. And we work with local artists, theater groups. There was a soap opera that was running on the radio that was very appreciated. There was murals on painted murals, etc. And that was a component that was very well received, and that really helped drive the message and increase the adoption of new hygiene practices. There was the economic empowerment of different women's association and farmers cooperatives, both in agriculture and livestock production. And finally, capacity building that came as a whole across the local district government and user associations, and even up to a higher level with the utility company and the ministries we were collaborating with. So I think that's one of the factors that we see, is that the project was aiming to work across different levels, at the local, regional, and national level, but also in different sectors, to try and build that resilience that is needed in this context, because of the change in climate, but also the security situation that was evolving very rapidly. We have some examples of activities here that were implemented. This was done using a demand-led approach and through value chains that were identified by the local stakeholders. So the small-scale irrigation, different activities for livestock, the community water supply, and different, as an example, some social art that was happening on school latrines or in community theater skits, etc. There were many challenges for water availability in the context of climate change. There was a very detailed assessment done for water demand and hydrological modeling to confirm the availability, and different interventions were planned to make sure that availability is increased or maintained in the future. There's some challenges from an institutional and financial point of view, mostly in terms of the implementation environment, the many competing demands. You have the mining company that wants to do things in a certain way. You have the donors, you have the government, but thankfully you managed to make everyone come at on the same page and agree. And the increased security risk, that was really an important factor throughout the implementation, because it changed so much, and we had to adapt very very drastically in terms of approaches and strategies. So I think that the main lessons learned that we wanted to present today were that the approach to intervene across different sectors was key to build that resilience, and more importantly, to be able to be very flexible and nimble, because we had to change so many things across the during the course of the project. And our great partners, IAM Gold, Global Affairs Canada, and OneDrop allowed us to do that, and really that made a huge difference to be able to achieve sustainable results in the end. So that's the main key points that we wanted to present today in terms of the and we wanted to highlight the unique partnership that could be that managed to get developed with extractive companies operating in the region, because sometimes these are seen as actors that can be a bit anti-development, but they sometimes have great goodwill and capability to play a big role in the development of a region. And they were very instrumental in achieving the results that we've seen for the ESED Sahel project.
Thank you very much, Maxime.
Thank you.
Time. Thank you so much. And thanks for highlighting also the need for flexibility and agility. I can truly imagine that must be a critical factor for you. So thank you. Now we're going down under. I'm sure you've heard that joke a million times, Annette. Sorry about that. But it's very true in your case, because you have worked a lot with soils. And I know that you are going to highlight that in your presentation. Annette Cowie, you're a professor at the University of New England in Australia, and you also have many other engagements. Please tell us about this. Now it seems we lost Annette for a minute.
Oh, sorry. Is this working now? Are we good now?
We can hear and see you, but your slide is, at least on my screen, half.
It's what, sorry?
It's sort of been cut in half. Oh, there we go.
Half.
Now it looks perfect.
Is it?
Thank you.
Oh,
yeah, now it's
okay.
Perfect. You go.
Let me start again. Sorry. Thank you very much for the opportunity to speak in this interesting event today. I'm going to be scaling right out and talking, I guess, at a global scale and talking about international policies, about the various initiatives that are enhancing the prospects of building resilient multifunctional landscapes. I'm talking about land as the common ground between the Rio Conventions, the three multilateral environmental agreements on climate change, biological diversity, and combating desertification. The IPCC's special report on climate change and land that was released in 2019 really highlighted the very close relationship between climate change and land. It showed how humans have, in fact, already exploited more than 70% of the ice-free Earth's surface, and more than a quarter of the land is actually suffering from degradation already as a result of human activities. The land is, of course, under pressure as a result of unsustainable land management practices and growing populations, deforestation, and urban expansion. In fact, the soil is being lost 100 times faster than it is being formed. And climate change is exacerbating that. The increasing frequency of droughts, for example, is leaving the land bare and prone to erosion, which of course further degrades the land and contributes to climate change itself. And this is largely a result of our modern farming systems based on cultivation and chemicals, which are leading to about 1/3 of the world's greenhouse gases. But this very close relationship between climate change and the land is actually also a benefit, because it means that if we manage our land better, if we apply sustainable land management practices, we can contribute simultaneously to climate change mitigation. When I talk about the land, I'd just like to clarify that I'm talking not just about the soil, but about the whole landscape, including the water, the plants, and the animals associated with the land. The benefits of sustainable land management in addressing land degradation are well recognised, for example, through the work of the UNCCD, which has introduced the initiative called Land Degradation Neutrality. Now, LDN is an initiative that aims to achieve no net loss of healthy and productive land, assessed at a national scale. It's actually one of the Sustainable Development Goals. It's target 15.3. Countries need to restore degraded land to counterbalance any losses expected due to unsustainable land use or urban expansion, for example. And LDN encourages an integrated landscape management approach, encourages integrated land use planning and land management in order to apply a mosaic of land uses, conservation, production, and settlements across the landscape. One of the key sustainable land management practices I'm sure you're all aware of is building soil organic matter. Practices that build soil organic matter are those that maintain plant cover, enhance plant productivity, address constraints such as fertility or acidification, and that minimize the disturbance of the soil, minimize the land that's left bare, such as from overgrazing and from cultivation, and apply organic amendments. Now, soil carbon management is estimated to be able to deliver mitigation from a technical perspective of up to 10 gigatons of CO2 per year on a global basis. And building soil organic matter doesn't only sequester carbon, it also enhances the health and the productivity of the land. It increases infiltration, for example, that thereby reduces erosion, reduces the risk of eutrophication. It also increases the water holding capacity of the soil, which contributes to climate change adaptation and contributes to addressing food insecurity. Sorry, I'm not sure whether, there we go. Another practice I'd like to mention under sustainable land management is the integration of vegetation, perennial vegetation, into agricultural landscapes. So this could be in the form of agroforestry or planting shelter belts, windbreaks, planting environmental plantings to enhance biodiversity. And this all sequesters carbon at the same time as building a resilience of agricultural systems. The third practice I'd like to mention is maybe not so familiar to you, and that's the use of biochar. Biochar is produced through pyrolysis, which means heating organic matter under a low oxygen environment. It produces a product which looks like charcoal. It can be done at a wide range of scales, from that small cook stove in the middle at the bottom through to plants that process 2 to 4 tons per hour. And it also at the same time produces a combustible gas that can be used as a renewable energy source. But the interesting thing about biochar from a climate change mitigation perspective is that this charcoal-like material is very resistant to decomposition. It lasts in the soil for hundreds to thousands of years. Now, biochar research has shown that biochar can have some very useful benefits in terms of sustainable land management, improving the soil health from a physical, chemical, and biological perspective. It is a strong absorbent, so it can immobilize organic and inorganic contaminants in the soil, reducing their uptake by plants. It contributes further to climate change mitigation because it can reduce the emissions of the powerful greenhouse gases, nitrous oxide and methane from the soil or from composting manure, for example. And it reduces the leaching and volatilization of nitrogen, which can enhance the nutrient use efficiency of the fertilizer that you applied. It also has the very interesting property in combination with the right clays, so not in every soil type, but certainly in some of the most common soils across the world, in particular in the tropics, to stabilize newly added organic matter that leaks out of plant roots in a process known as negative priming. So it can continue to build the soil carbon levels over and above the amount of carbon that's contained in the biochar. But please remember that biochars actually vary widely depending on the feedstock that you use to produce it and the pyrolysis conditions. So you do need to choose the biochar carefully to suit the context where you will apply it. Back to the IPCC special report on climate change and land, it looked at a very wide range of land management practices and identified that many of them contribute simultaneously to climate change mitigation, adaptation, addressing land degradation, and contributing to food security. But it also highlighted some practices that could be a risk, and these are afforestation and growing biomass for bioenergy or biochar, which it identified could contribute to food insecurity if they are grown in places where they displace food production, or loss of biodiversity if they displace natural systems. So it's important that the right SLM practices are chosen and applied in the right places at the right scale. And this is where consideration of resilience is important. When I say resilience, I'm talking about the capacity of a system, such an agro-ecosystem, to absorb shocks such as climate change and recover from those. It's the coping capacity of the system. And the importance of resilience is it helps you to think about the future, what the shocks are likely to deliver for that system, what the vulnerable elements are, and to focus your interventions on enhancing the coping capacity of the system, or more importantly, to identify if you need to actually transform that system because it may be non-viable in the future. RAPTOR, the Resilience Adaptation Pathways and Transformation Approach, is a tool that helps people to understand resilience, apply resilience thinking, and to identify those vulnerable elements of their system and to devise pathways for adaptation or transformation. I'm showing on the screen here the soil and land capability mapping approach that's applied in New South Wales, where I live, which is used to identify which parts of the landscape are suitable for different types of land uses based on the slope, the soil type, and the location relating to infrastructure, for example. The Land PKS tool is another tool that may be relevant. It's actually a mobile phone-based tool. It relies entirely on illustrations, on simple pictures to help landholders to understand the potential of their soil. And it's recently been linked to WOCAT, the large global knowledge sharing platform about sustainable land management practices, and the Carbon Benefits Project, which has produced a tool to estimate the carbon sequestration associated with land management, so that project developers can identify the most suitable SLM practices and the mitigation benefits they can deliver. I'm being given a hurry up, so I'd just like to conclude by saying that there is a convergence of the pressures from climate change, land degradation of population, and of the initiatives that are seeking to address these, increasing the recognition of the pivotal role of the land and preserving the land resource base. And building resilient multifunctional landscapes is one way that we can contribute simultaneously to climate change mitigation and adaptation. It's not easy, it requires good governance, but it's worth the extra effort to deliver the opportunities that can be achieved from this. Thank you very much.
Thank you very much, Annette, for such an exciting and intriguing presentation. I'm sorry to be rushing you all. It's just that we need to have some time for the discussion as well. So with that, I would like to hand the floor to my colleague, Noreen Anisha. Noreen, you are doing your research with Oregon State University, and you have also been instrumental in planning for this seminar. So I would really like to thank you for all your hard work, Noreen. So you're part of the scientific program committee. And you will lead us from dry to wet a little bit. You've worked extensively on wetlands. The floor is yours, Noreen.
Thank you so much, Louise. I'm going to present about nature-based solutions in water and creating synergies between adaptation and mitigation. So I have basically divided this presentation into three parts. Firstly, I'm going to talk about water for nature-based solutions, or NBS. And then I'm going to talk about climate change mitigation potential of water bodies. And I'm particularly going to talk about wetlands and inland water. And lastly, I'm going to talk about how NBS with water can actually create a bridge between adaptation and mitigation. Now, nature-based solutions, or NBS, is a relatively new concept, which gained more traction after we realized impacts and limitations of technological solutions, more so in the last few decades. For example, let's talk about dams. When dams are built, they alter the hydrology and ecosystem significantly. When they're removed, the ecosystem and hydrology goes through a big alteration again. From 1990 to 2015, 900 dams have been removed only in the US. So gray infrastructures like dams are capital and energy intensive, designed based on historical hydroclimatic assumptions, and are often inflexible in operations and design, and they address a narrow set of water issues. They can last for decades or centuries, but in a planet with a rapidly changing climate, the operations and purpose can be easily violated. Just this year, we have seen dams collapsing in China and Sudan due to unexpected and out of ordinary heavy rainfalls, proving that gray infrastructure can be vulnerable to failure, especially under rapid climate and land use changes. Now, NBS, on the other hand, being much less resource intensive, utilize the ecosystem functions. Now, the ecosystems are not static as they evolve over time. They can be highly adaptive to changing environmental and risk conditions, so potentially and often potentially exceeding the design lifetime of gray infrastructure. This flexibility of ecosystems is what works in our favor. Nature-based solutions definitely long-term and large-scale approach compared to gray infrastructure, which are often site-specific, contextual, and single-purpose. In water sector, while NBS can provide the similar hydrological solutions, can also provide co-benefits related to disaster risk reduction, climate change adaptation. And nature-based solution can take time to deliver benefits compared to gray infrastructure, which provides instant gratification. But unlike gray infrastructure, natural solutions can be self-sustaining for a long period of time with protection and active management schemes, while providing you a diverse set of ecosystem services. Now, how water with NBS works? Well, ecohydrological connection for water can play a huge role, which means how the surface water interacts with groundwater, the vegetation, the biogeochemical dynamics. Many of the changes in above and below ground vegetation, land surface, and soil characteristics interact in complex ways. The ultimate impact of NBS depends on how this changes in this complex system interact with one another. The figure on the left illustrates an example. The spatial and temporal scale impact of NBS can be very different. Local impacts typically manifest rapidly, for example, for improved infiltration or reduced runoff. Large-scale impacts like groundwater recharge or downstream flow alteration can take more time and are also dependent on the extent of the changes in vegetation, surface, and soil properties to significantly alter landscape scale hydrologic functioning. So here I have a chart that outlines some example of NBS for water resource management. First, say, as a nature-based solution for biological control of water body, you can do forest preservation, you can protect or construct wetlands, create riparian buffers, or connect rivers to floodplains. The gray alternative would be making a water treatment plan. Again, if you look for the riverine flood control, the NBS solutions are similar, but the gray solution would be making dams or levees. And if you go closely through this chart, which you might be able to do later, you can see that one NBS approach for, say, protecting or restoring wetland can help with biological control, can help with flood management, can help with water temperature control, but the gray solutions can only address a specific issue at a time. I would like to introduce or discuss this new book that just came out last month, which discusses elaborately on nature-based solution and water security. So if you're interested, you can definitely check it out. Now, I would like to discuss climate mitigation potential of water. Let's discuss the wetlands first. Well, wetlands can include almost all aquatic systems, but here we are referring to bogs, fens, swamps, marshes, peatlands, mangroves, salt marshes, estuary, etc. as wetlands. Most aquatic environments can work as greenhouse gas emission sources and sinks, particularly wetlands, such as peatlands and blue carbon ecosystems store large amount of carbon. Peats cover only 3% of the world's surface, but have the potential to sequester 30% of the global emissions. Blue carbon ecosystems are also known for their carbon stocks. The concern about the wetlands is that they're the most rapidly declining ecosystem in the world. They're declining 3 times faster than forests. When wetlands are drained, disturbed, or destroyed, they emit the carbon they have stored for thousands of years. So when our wetlands are not taken care of, we not just lose our future natural carbon storages, we emit all the carbon that these wetlands had stored from the past. So you see, we are finally on our race to net zero by 2050, and losing carbon storages like wetlands, as well as emitting the stored carbon from these wetlands, will not support our cause. Now, talking about inland waters, rivers particularly have not been taken very seriously for climate mitigation until very recently. Rivers can emit greenhouse gas, and not considering that in our race to net zero would only undermine our efforts. The truth is, inland waters can work as both source and sink for GHGs, or greenhouse gases. GHG emission is found lower in large rivers. Again, we have seen that forested rivers were most frequently found to have low GHG emission compared to urban and agricultural river. They can also behave as nitrous oxide sinks through the process of denitrification, turning nitrous oxide into nitrogen, particularly when they're connected to wetlands. But the nutrient input, the human activities, global warming can increase emission not just for rivers, but for lakes, reservoirs, and other lentic waters. But here's the catch. The new IPCC report talks a great deal about how little we know about emission from rivers. We know there are evidences that rivers are emitting, but we do not really have an organized, concrete knowledge of how to help it and what to do about it. So how can Nbs create a bridge between adaptation and mitigation? So you see, I talked several times how conserving and restoring wetlands is a Nbs for water quality control, for flood control, for disaster risk reduction, right? Natural wetlands are generally carbon sinks, unless it's disturbed. So rather than eliminating wetlands or disturbing the wetlands, we can rather utilize them as nature-based solutions and have mitigation benefits. Blue carbon ecosystems are amongst the most productive ecosystems on the planet, growing quickly, storing organic carbon in the biomass of living organisms, soil, and sediments. And blue carbon ecosystems are great Nbs for coastal protection. The thing is, carbon sequestration is not necessarily the most valuable ecosystem service provided by the aquatic system. Watershed scale aquatic system management comes with natural solutions and also has the potential to sequester carbon. What we can do is design nature-based solution schemes with the full set of ecosystem services in mind alongside carbon sequestration. Greenhouse gas production in aquatic system is fueled by the inputs from the watershed. Effective emission reduction entails coordinated approaches for land management, restricting nutrient loading, maintaining and improving ecohydrological connections. This similar watershed scale management is required for proper utilization of the nature-based solutions as well. So for example, there's a very easy example that flood event occurring due to climate change.
Sorry to interrupt, but it's time to wrap up.
Yeah, I have the last line. So you can build a wetland, which is a nature-based solution, but also has the mitigation potential. So you see, nature-based solutions in water and climate mitigation can be pretty complementary. And that's all from me. Thanks a lot. For any questions, you can email me at anisha@oregonstate.edu. Thanks for the heads up, Louise.
Thanks, Noreen. That must be the fastest wrap up in history. Thanks so much. And thanks to all presenters for really trying hard to stick to the time. So we have time over, thankfully, for an exciting panel discussion. And I only see the chat in Zoom, so I cannot follow Passable. the presenters can, and as mentioned, you can ask questions for the presenters in Passable so that they can respond later on. So I thought I would start with you, Annette. Sustainable land management is what you talk about, and a mosaic of different options. And I think, to me, that was a very hopeful presentation. There is a lot to be done, really. However, I was very intrigued about what you say about biochar. What I have seen is that biochar is receiving a lot more attention recently than previously, at least. But it doesn't seem that people really adopt it. But why is that? What are the challenges here? What should be done?
Thank you, Louise, for this question. Yes, biochar, as you probably heard me being excited about it, seems to offer quite a lot of potential, both in terms of mitigation and adaptation and other benefits. But it's actually a very new science. Soil scientists have been looking at biochar only for the last 20 years, although it has been used by indigenous communities for hundreds to thousands of years. It's kind of new to modern agriculture. And I guess while it's still in the scientific domain, there's some uncertainty amongst landholders and policymakers about biochar. Also, I mentioned that its properties vary widely. And so people's use of biochar has delivered a wide range of results from big benefits to small benefits or no effect, and occasionally negative effects because biochars haven't been chosen carefully. And so people have been, I guess, wary as a result of that. People are also concerned about sustainability implications if a demand for biochar causes deforestation, for example. So it's very important that we have sustainability governance about the biomass sources that are produced for biochar, but same for bioenergy. So I would say that the constraints are that currently it's a small industry, so biochar is expensive, other than in China, where they have actually really increased the production to a large scale, and it's affordable. But elsewhere, it's kind of a niche thing because it's stuck in a chicken and egg situation. While it's expensive, there's not high demand. While there's low demand, there's no justification for building large, expensive plants. But it's certainly becoming recognized now, having been identified by the IPCC as one of the 7 technologies for carbon dioxide removal. There's a lot of interest now in biochar, and I'm sure that's enough from me on this topic. Thank you.
Well, it's very exciting. I mean, both you and Noreen, you bring up the importance of soil carbon, and in my setting here in the boreal forest, that's where we have our carbon, right? So Noreen, you clearly highlight the importance of wetlands. Are they receiving enough attention, do you think, or is there potential to restore and rebuild wetlands to a larger degree? And if that is so, what should be done?
Thank you, Louis. So what I can say, I think the right way to put it would be wetlands are getting increasingly more attention. If I have to draw an example, that would be in 2019, when we were analyzing the NDCs, we found there were only 12 countries in the world who had included wetland-based mitigation in their NDCs. As of August 4, after analyzing the revised and updated NDCs, it's seen that there are now 15 countries including wetlands for mitigation, 10 countries including mitigation based on blue carbon ecosystem. So not a huge change, but it's increasingly getting more attention. There is a little bit of light at the end of the tunnel. We wish the light was brighter, but there is a little bit of that. But I believe there is now more conversations regarding that, more researches regarding that. There are more financing tools, management tools, policy tools being discussed to integrate wetlands as nature-based solutions for their mitigation, and not just blue carbon ecosystems, but also freshwater wetlands, not just peatlands, but also swamps and marshes. So, yeah.
Well, we see here in Europe, we're looking forward to a potential restoration law from the EU, which I think would have great impacts for European wetlands. We'll see about that. I was curious, Luca, you spoke about Not, of course, the great thing about launching a project during COVID. I can imagine that. But if it hadn't been for that, what would you say, what were the enabling factors behind your project? Why did it take off, and what were the critical barriers that you were able to overcome?
So I think the biggest enabling factor was actually our client, the Greater Visakhapatnam Municipal Corporation, sort of interest in pilot these sort of solutions for climate change resilience and mitigation, because also they feel the urgency of climate change and adapting to those challenges. And as well as, this is very aligned also with our ADB strategy 2030 and our sort of targets for climate to finance, climate mitigation and adaptation. And also the fact that there was a master plan. So something that, already, something that, okay, you already see a vision from a pilot actually to something that would be at scale. In terms of challenges, I think, the biggest one was actually some institutional coordination in a way, because, adaptation and mitigation often they do fall in different institutional responsibilities. And the fact that I think also, as Nuri mentioned, I think the benefits, the fact that some benefits are not really immediate. Especially on the water conservation. So the fact that we really need to explain in detail about, what are, the real benefits, and when this will happen. So I think those, in a nutshell, those are, the sort of enabling factors and challenges from our end.
I can imagine. I mean, it's a complex project which spans different sectors, and of course, different actors benefited from in very many different ways and over time.
Correct. Yes, and sorry, one last thing. Just the fact that it's a pilot within a wider project. I mean, a bigger project. Also, have everyone focus on this small 5 million pilot rather than also the bigger $400 million investment. That's also was actually also a bit of a challenge. But yeah. Okay, thanks. Sorry.
Thanks. Maxime, your project that you have worked on now for 5 years, is it? I mean, you do so many different things. Did you ever run into any conflicts, looking specifically at the topic for today's session? In other words, sort of conflicts between resilience and mitigation, or are they all synergies, or is it easy?
No, thank you. That's a very good question. And I think that when we were initially scoping and designing the project, well, that would be 7 years ago, around 2014, there was a lot of hope to kind of bridge and transition between adaptation and mitigation solutions. And there's still some hope left, in terms of the phase 2 and everything. But we faced the reality that with the changing situation there, with the context that became more of a crisis situation with the displaced populations and with very, very vulnerable population in terms of livelihoods and in terms of water supply and everything, we had to, in the end, pivot a little bit and focus more on building resilience within the overall system. And that's why we ended up focusing a little bit more on adaptation through different, both on the water side, but on the agricultural and livestock aspects, with very targeted interventions in terms of improved techniques and capacity building and training, and some soil and water conservation that were very critical for in the local area. But there's still some plans. As an example, it was very interesting to see Luca's example of the floating solar on the water reservoir, and that could be something that could very well be looked into as an example to supply the power for the drinking water treatment plant, and that might be that might be very interesting options in the future. So we're keeping our eyes open, but in this situation we had to make that pivot and work focus a little bit more on adaptation versus mitigation.
which I think is completely understandable, right? Of course, first you manage risk and then you can aim for other things. Unfortunately, it is now 4 o'clock sharp Swedish time, which means that we're running a little bit behind time. I have lots of more questions for the panel, but unfortunately, I'm not able to ask them. So I'm handing over to my colleague, Guillermo Donoso, to wrap up this session. Guillermo.
Thank you so much, Luis. Thank you all for your thought-provoking presentations and for highlighting the innovations in the water sector that facilitate synergies between mitigation and adaptation. This session and your participation moved us towards our objective of analyzing how water resources provides important elements to facilitate the synergies that we are interested in between adaptation and mitigation. You showcased, for example, Luca, the synergies between adaptation and mitigations with important lessons for scalability by identifying your enabling factors and the critical barriers you had to overcome. Maxim, on the other hand, highlighted the importance of broader engagement to be able to advance in these objectives, the need for flexibility in the design. Annette brought us back to the pivotal role of land, how land use transformation and ecosystem restoration contributes to increased resiliency. Finally, Noreen also showed us that nature-based solutions are an effective mechanism to bridge the adaptation and mitigation divide that we have observed. The good news that I derive from all of your presentations is that there's a lot happening and that there are innovative solutions, and we need to bring them forth and communicate them as you were participating with us today. A closing remark, I remind you that our seminar is in 3 sessions. Our 3rd session will wrap up our seminar with the participation of experts in a panel who will also be participating with youth representatives from across the globe for an interactive discussion on how to move forward. How do we take these innovations and scale it and replicate so that we can move forward in these synergies? Once again, thank you all for your participation, and we hope to see you in our next session.